Hello, my name is MAlMamari, and today um, I'm gonna do the second KI video presentation, and it's about audio backend system. So, in the beginning, let me introduce myself. As I mentioned before, my name is MAlMamari. I am from Oman. It's a country in the Middle East, as you can see in the map to the right, and in this semester, I'm doing my junior year. I'm taking 3 ECE courses and also CO 150. So I'm taking ECE 311, ECE 331, ECE 341, and also CO 150. So in this short video, I will try to connect uh, all the stuff and what we have done in the pre-work of KI2 to the courses we are studying right now. So I will try to explain this device, which is audio backend smartphone. So it's basically audio system of a smartphone. I'll try to explain it using the methods we have studied in all of the 3 courses we are taking. So we can see this device, we have an input, audio amplifier, and output connected to a speaker which translates the electrical signals to sounds. We can see here also the definition of audio power amplifier, which is an electronic amplifier produces low power electronic audio signals such as signals from radio receivers or electrical guitars. Here we can see the schematic of the device, or basically the circuit. So we have an input signal, which is a DC voltage source connected to a MOSFET. So we have 2 MOSFETs, and there are both NMOS. We have also 5K resistance, and the output of the circuit is connected to the speaker. So now I'm gonna try to relate what we have analyzed in this device to 311. So as we can see from the schematic I just showed you, the system, the amplification system, is a time invariant system, and that because the input of the system does not change over time. The system also is a linear system, and that because it passes homogeneity and additivity as we studied in 311. So the importance and the significance of 311 comes when we use especially sinusoidal inputs. So for one of the questions we had to use sinusoidal input, and to get the output of the circuit or of the system we had to apply the methods we studied in 311, which is basically Fourier transform. So we can see here in the sketch the system is linear because it's obvious that it repeats itself over time and it's periodic. So when we come to ECE 331, we have in the circuit, as we can see, we have 2 MOSFETs, and both of them and MOS are operated in the saturation region to ensure they are linear amplification. We also the transistors, we have transistor biasing both for both of the transistors, and that to ensure the linearity of the system. So basically, transistor biasing is the process of setting a transistor's DC operating voltage of current conditions to the correct level so that any AC input signal can be amplified correctly by the transistor. We have also calculated the gain uh, of this circuit. So we used like a lot of stuff that we have studied in 331 to correctly analyze the circuit and get the gain and the output and also the input. Okay, so I think the party starts here when we are start talking about the relationship between this device and ECE341, because the speaker converts the signal to sounds, uh, and the principles which are used here are like basically electrical fields and magnetics and all of this stuff. So in order to convert the signal to sounds, the speakers contain an electromagnetic, which is a metal coil that creates a magnetic field when an electric current flows through it. This coil behaves much like a normal magnet that changes the polarity of magnet depending on the direction of the flowing current. And inside the speaker, the electromagnetic is placed in front of the uh, permanent magnetic. The permanent magnetic is fixed family into position, whereas the electromagnetic is mobile. As pulses of electricity passes through the coil, the electromagnetic and the direction of its magnetic field is rapidly changed. So this is basically how the KI2 pre-work connected to ECE341. And finally, here we have the citation slide. So thank you for watching this video, and also thank you for reviewing it, and I wish you are going to do well in your exams. Thank you, and have